I would like to have two acknowledgements given. Over the last 2 weeks for this session, I have been interacting with a few of the team members here who are organizing the event. What struck me most in during these interactions was the passion with which they approached this whole event. Few of my colleagues are also here in this room, and within a small group inside Cyber I am also one of the members who try to do something like this within that organization, and I know the difficulties associated with it, right? So very often the difficulty is not so much as to identifying the topic or identifying a speaker or getting the venue done. Most difficult task usually is to get an audience inside this event to sit and listen to this. Like probably I can see some known thing that you all experienced. So they were telling me that they have been doing it successfully for the last 3 years. I can very well imagine the dedication and the passion and the effort that goes behind this. So first I would like to acknowledge that passion. And second, my acknowledgement goes to all of you who have taken the real initiative and pain to come for this event. I'm sure all of you with your own activities, in your own respective projects, but in spite of that, you have taken this real initiative. I would call it initiative rather than anything else. It's a self-driven initiative, right, which asks you to register for an event like this and come and be here on time. So, round of applause for ourselves as well. So, with that, we'll start our session. I think I'm talking to the move to the side. Before we start with the deck, a few icebreaker questions that they call it, right? As the session says, introduction to DevOps, the most common icebreaker session will be how many of us are familiar with DevOps. I would just like to speak with question with you. Instead of asking how many of you are familiar with DevOps, I just want to understand how many of you are actually practicing DevOps as part of your day-to-day activities or projects in your organization. How many of you are actively practicing DevOps today? Okay. Fine. The second part of the question would be, how many of you are aware of DevOps? Awareness can be from any form. It can be attending sessions like this. It can be by reading it yourself, or it can be through any form of factor. Aware of DevOps already. Okay. So does it mean that a significant part of the people here are not had any introduction to DevOps before? Okay. So no major rules in this presentation. Other than that, I would like the session to be very interactive as much as possible. Because I myself will explain that we are into DevOps. I do not consider myself a DevOps expert. I've had some personal hands-on experience with DevOps by working through one of the projects with our customers. And I would like to share those experiences with you. So anytime feel free to interact or ask questions or even share your experiences or views. Okay? Fine. Few more questions. How many of you have worked with the waterfall project? Have worked or already working or still working? Okay. So I always started my career with the waterfall model of project execution, project execution and all those. And how many of you are actively practicing agile in your So my question is this. What happened? The question I have today is DevOps and agile routine. Idea. Okay. I like that. For those of you who have an idea, is DevOps and agile routine? Why not?
Event goes live, so they could also listen to you.
Probably, okay, those of you who are following waterfall model, which is the alphabet that comes to your mind when you think of waterfall? It takes the wheel model of project execution, right? Because on one side, the developers need to do their design, requirements, implementation, and development testing. Whereas on the other arm of the wheel, who sits? Who sits on the other arm of the wheel? The tester is, yes. So if you look at it, the wheel is like this. The fundamental principle is that the drawback of waterfall is always actually that the developer and the QA system separate eyes. Makes us designs and does his implementation. The tester sits in some other part of the world, even if in the same office, in total isolation, in almost isolation from the developer, sitting and designing his test plans, test data, test cases, and so on. So only when the developer is ready with his implementation and unit testing has been completed, something is handed over to the tester where he takes up the testing. So those of you who have not had any experience with waterfall, a quick introduction to what waterfall is all about. One more question, though it might look a little totally unrelated to the topic, but I would still want to ask this question. Those from Tata Elxsi can keep quiet. What does a cable service provider do? A cable service provider. Or can you give me an example of a cable service provider in Kerala? Yes. So what does a cable service provider do? Yeah. So they bring video, voice, and data to your house through a cable. Is Tata Sky a cable service provider? It's a DTH provider. So that's the difference. You will understand why I asked this question later when I come to the next. A cable service provider is someone who brings you voice, video, and data to your home through the coaxial cable, right? Any more ice on the surface? Do I have to do still ice breaking? Okay. So one request again, only one rule for this entire session. Please help me make it very interactive. Yeah? So let's start the session with a game. These are the numbers on the slide. It says 15,000 developers in 40 plus offices, 4,000 plus projects under active development, 5,500 plus submissions per day on average, development on a single branch. All submissions by the developers go into the head or the trunk or whatever you choose to call it. 20 plus sustained code changes per minute, a peak reaching up to 60 plus submissions. So if you look at it, the 15,000 plus developers spread across the 40 plus offices together can make up to 60 plus code changes in a single minute, and they all submit directly to the branch. 50% of your entire code changes monthly, and 75 plus million test cases. I want you to realize it. 75 plus million test cases is being run every single day. Is it any of our companies? Any guess which company this can be?
Google, Facebook, Google,
Amazon?
Google,
Facebook?
Amazon.
Yeah. One more slide. Something similar, but again, the ones which have been put in bold, I just want you to realize, read it a little carefully. Pushes changes to production every day. Those of you who raised your hands for the waterfall model of execution, I just want you to relate back to your scenario. Changes to production. Production meaning the end customer. Changes to production every day. 1 billion plus active users at any point of time. 13 plus million lines of code overall. 15,000 plus commits per month. Most changes having impact across platforms. Changes from submission to production get pushed out in less than 60 minutes. What does that mean? Developer checks in something in your subversion or your repository. It gets into the production. It gets into a live customer in less than 60 minutes. Updates to production made at full live capacity. There is no downtime. You do not bring down your entire system to push a new release into the market. So the update is happening live. Guesses? The same names come, right? And you're realizing it's the same names that keep coming. It's either a Google or a Facebook or an Amazon. And this time it is Facebook. Okay. Now comes a real life story. My own personal encounter with whatever little I know about DevOps. So as was explained here, as I used it for my introduction, I work for Tata Elxsi, and in Tata Elxsi, I am working with a cable service provider in the United States. So now you can relate to why my question came, because the examples, the scenarios I might use will mostly be from that industry. So my customer is the world's largest cable service provider based out of the United States. Their customer base is up to millions, not like Asianet, it's up to millions. And we have been working with this customer since 2009. So we are completing the 7th year with this customer next year. Next month. And when I started working with this customer in 2009, they were trying to bring a new product, a new application, a set-top box application into the market based on a new technology. It was a Java-based set-top box application written from scratch, and they were trying to bring it out into the market. And we worked for that product with this customer in 2009, 2010, 2011, 2012, 4 years, right? And it was in waterfall model of project execution. And in 2012, there was not a single deployment in the market yet for this product. Whatever they were trying to bring out, there was not a single deployment in the market. 4 years down the line, in 2012, they decided and they announced that this project was getting scrapped. Now, this is the world's largest cable service provider, one of the richest companies in the US. 4 years into active development, you can just imagine the time, the money, the effort that went down the drain without a single deployment. Not even a single customer of this millions of customer base got to see that product that was in the making for 4 years. Okay, so 2012 they stopped it, but as soon as they announced the stopping of this particular version, they also announced the next version of their architecture, which is a total revamp, complete revamp of what they were trying to do. And the beauty of this is that they learned from their mistakes. So they switched over from the waterfall model. They analyzed very deeply as to why they could not bring out a single product into the market. We will not get into the details now, but probably if I have time, I will give you a few more details just for us to understand what are the types of analysis and thinking and planning that you need to do when you decide to go into something like an agile or a DevOps. And from day one, they did not go into DevOps. I want you all to realize that they did not go into DevOps from day one. They started with agile. They said enough of waterfall, we are starting with agile. And they started making small and small changes. And 2012, so they started their research work sometime earlier itself. So 2010, 2011 itself, when they knew that the other project was not going too well, they started doing their research work. But 2012 was when they announced to the world that we are going with something like this, and they started their full-fledged development in 2012. Just a recap, 2009, 10, 11, 12, 4 years of development, not a single product in the market. And the results from 2012 look something like this. 2012 was the first year in which they started the active development of this product. And already by end of 2012, M stands for million. 1.5 million boxes or 1.5 million customers already had this new architecture or the new product in their set of boxes. 2013, 1.5 became 2 million, but there on if you look at the pace of this deployment, 2014, 5 million, 2015, for losing their customer base year on year. For the first time with this product, they have started increasing their customer base because this product, you can just do a search if you want, go back. It's called the Xfinity product. This has been a success and they have been able to make huge deployment scales with this. I also want you to look at this green, this green line over here, which tells the team size, which is supporting this deployment. So when your deployment goes from 2 million to 15 million, I do not see a similar steep rise in the team size, which is supporting the deployment. Again, a key point to note. Why or how this is achieved, you can see in the later slides. But this is how you are able to scale up with a non-linear increase in your team size, right? So from here, now why did I share this story in the beginning? Few reasons why I shared that. Number one, the initial 2 slides, we were all very happy to say that it's a Google and the Facebook. So I do not want any of us in this room to have the impression that DevOps is only for the Googles and the Facebooks of the world. It is not. And this, again, as I said, this was a company which failed miserably to bring out a product after trying for 4 years. And in spite of moving the transition, they were learning in the process. They were doing the transition, and starting from year 1, they were able to bring out successful deployments in the market. And they are still not in the active stage of DevOps. I want you to again realize this. They are not yet in the mature stage of DevOps, which is why the numbers that you saw in the slides like Google and Facebook are not the same. They do not know how to use not yet. They are not able to release changes to production every day. They still struggle at times to bring out a release 1 month. At times they succeed, at times they have problems, at times they have to roll back what they have deployed. So this is not a company who is there in the mature stage of DevOps. So the second reason why I'm sharing this story with you is to realize that you do not have to reach the mature stage of DevOps to start reaping the benefits. As long as you plan it out well, you take the right initial steps, you can start getting the benefits as early as the first or second year of your transition. And the third reason why I brought the story in the beginning is just to let you know that I have some hands-on experience in DevOps. It is not just that I've Googled up things from internet and trying to present. I have seen this company since I worked in the initial 4 years as well as the second 4 years of their development. I've seen how things change. And personally, for me and my team also, it was a big learning experience of how the world changes today, right? Sure. Any questions so far? Any experiences to share? Any views, thoughts? So this is a definition, right? What does it say? It's continuous innovation, seamlessly released to production multiple times a week without impacting the consumers. A few things are very important here. Your products or your changes, your enhancements are getting released to production multiple times a week without impact to the consumers, right? So if I take my client, what happens if your Asianet box doesn't work every alternate day? You will naturally disconnect and go to somebody else, right? So you cannot afford to impact your consumers a lot. There have been cases where the consumers are impacted, but you should be able to roll it back fast enough. So that's what DevOps is all about. This is
If I remember right, this is from Wiki, the definition, but I have underlined a few things. DevOps aims at establishing a culture and an environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. Once again, I did not say DevOps is a tool or DevOps is a framework. I said DevOps is an environment and a culture. Very important for us to understand. When they were asking me for the material to put in the flyers, also they asked me which tool should we put. I said DevOps is not about any single tool, or it is not even about a set of tools. It is more about how you approach a problem, your mindset towards it, how you plan it out, and how you change your culture. To move from waterfall to DevOps, it really requires a cultural shift. So to understand the concepts behind it and be willing to get to that change, that will be critical rather than using a set of tools here. This question we briefly touched upon, and I thought we all agreed that we are having difficulty in seeing. We all agreed that DevOps and Agile are not the same, right? But why am I still going to discuss Agile? I'll be spending a few slides now to discuss on Agile. Why? Because I think somebody told that, what did you say? You said Agile is? Agile. Oh, okay. DevOps, it's actually not that way. DevOps doesn't help us to achieve Agile. Agile was a transition. If you look at how the world transitioned, from waterfall, they went to Agile. And from Agile is when the DevOps came in. So that was a natural sequence of transition. And if we understand the Agile properly, concepts behind Agile, what is important in Agile, if we follow that properly, we will be in a much better position to appreciate DevOps. So that is why I'm going to spend a few slides here on the Agile methodology. So I think most of you will be familiar on what is a conventional waterfall model. It's like a cascaded waterfall. You start with requirements, you design your complete system, you do your full implementation, then you hand it over to the system QA team to do the verification, and then the product is released and gets into the maintenance phase. So what is the earliest before you can see something working here? At which stage do you see something actually working? In the verification phase, right? Until then it is all in paper, right? Until then it is all in paper. Requirements, design, implementation, and verification. And when it reaches the verification, that is when you can see something really working. Whereas what is different in Agile, if you look at it, Agile also goes through all these stages: design, development, assurance, and deployment. But what is different here? Yes, exactly. It is all in iterations. Anybody any day asks you what is Agile, make sure you bring that word, iteration. And there's one more word you have to bring in about Agile, sprint, and there's one more. Scrum, no, sprint, Scrum, and all, like somebody told, that they are all the different ways in which you can follow Agile. Agile is just a methodology. Sprint, Scrum, lean development, all those are TDD, all those are different processes by which you can practice Agile. There's one more term, we'll come to it. So if you look at it, the exact stages happen in an Agile, but it happens in small iterations. And how long can an iteration be? 2 weeks, 3 weeks, 1 month, or 4 weeks? But it usually is no longer than 4 to 6 weeks, right? You do not make your sprint as big as 6 months or 7 months or anything. Your sprints usually is between 2 and 4 weeks. And what happens within this 2-4 weeks? All these things happen, right? So whoever is practicing Agile will be able to appreciate it very faster. You do a requirement analysis, you do a design for a small part of your feature, you implement it, you test it, and you make sure that it is ready for release within that 2 to 4 weeks itself. That is a change main change when you come from waterfall to Agile, is that everything happens in one sprint. One part of your product is ready, and then you go to the next feature and you start all over: design, development, implementation, and so on. So what is the earliest when you can see something working? Yeah, as early as your first iteration or maximum your second iteration, you will have some part of your product actually working. And why is that important? Why is an iterations and early feedbacks important? I'm sure all of you would have seen this. The inherent problems with communication, right? When a customer explains something, then the analyze designs, patches were applied, project leader understands, programmer writes. At every stage, there is some amount of information that is being lost. So in the end, what you get is something totally and drastically different from what the actual customer really wanted. So if it, now suppose this project was done in waterfall model, when will he realize that what is being actually developed is this? Only when it reaches a system verification or the system QA. Whereas, suppose these are the different phases in which Suppose these are the different stages in which the iterations were being developed. In the first iteration itself, if something like this comes out and your customer actually gets to see this, he will tell, oh, but I do not have something like this in the product which I have in mind, right? Immediately he tells you that there is something drastically wrong here. I do not have something like this. Let's sit and analyze what you are developing. And then in the end of the first iteration itself, you find out that what you have understood is different from what he had in mind. So that is the importance of early feedbacks and shorter iterations and having something demoable much earlier on in the cycle rather than waiting. And then there is also a different thing that, and actually, you know, this is a standard process flow of a Scrum. You said Sprint, Scrum, all this actually follow this, right? So you have your product backlog. You know that what you want to make is a big tire, but then you will slice it into different. So in order to make the big tire, what are the different parts that is involved? You break it into small slices. You take each slice as a sprint backlog, and within 2 to 4 weeks, you do one slice of this and you make it ready for deployment. So this was the second term I was looking for, a potentially shippable product increment. In an iteration, what you bring out is a potentially shippable. So if the condition demands it, you will be ready to release it as it is to the market, right? And it also believes in minimizing the waste, in that you slice it only when you are ready to eat. You do not sit in the beginning, you do not make the pizza and cut it into small pieces. So if this is your pizza, you do not cut it out fully. You just take what you're planning to do in the first 2 or 4 weeks, you take it out and then you slice it out, you design it, you implement, you test it, and once that chunk is ready, that is when you go and cut the next slice. Okay? So that's a fundamental principle of Agile, is that you do things in increments. And this again is what I was looking for, potentially shippable product. Now there are 2 ways in which I can do things, right? If I am planning to make a car, a BMW in the end, I can make it either in the first iteration, second, third, and fourth iteration, I have my car ready. I can also do it like this, and finally I have the car ready. So in both cases, at the end of 4th or the 5th iteration, I have my fully functional car ready. But what is the difference between 1 and 2? Sorry? Okay, so physical difference is that here all the faces are very sad, right? Until you reach the car, they're all very sad. And here, if you look at it, right from the beginning, they're all very happy. Why are they happy? Yeah, because he's getting something which he can use. Something, if not the BMW, he's still getting something which he can really use. In the second, okay, he is getting a next feature and added to it. Third, so his usability of the product keeps on increasing, unless in this case, unlike in this case where he has to wait till the end of your complete project. And this is a typical, though it looks like a joke, this is a typical pitfall that most of the people who are adopting Agile first time falls into. They might go into something like this, because in principle they understand the theory that okay, I have to do things in increments. So let me do first increment, let me do the second increment, third increment. But again, this happens because we really do not appreciate the principles behind why you have to do things in increments. The reason behind why you have to do things in increments is, one is that at end of each iteration, I have to get something which I can potentially sell to the customer and make some money. Why? Because your business, your environment changes drastically every single day. Probably if I planned out to make a BMW in the end, at the end of my third iteration, something happened. Either my money went for a toss, I'm bankrupt, or the conditions changed and the BMWs are no more required in the world. Something changes and you're deciding that, okay, I do not want to make BMW again, right? In that case, you can still make a stop. If not a BMW, you can bring a bicycle out into the market and get some money out of it. Clear? So I wanted to reflect back to the case study I told in the beginning, 2009, 10, 11, and 12. 4 years, they went on building something. Unfortunately, what they built was something like this. So in 2012, when they decided to scrap the project, they had nothing which could be sold out into the market and made money out of. Whereas in this case, if you do things like this, one is, if at all you decide to scrap your project at this point of time, everything is not lost. You can still try and regain something which you invested in, number one. Number two, and most important, is that you get early feedbacks. Now, what kind of an early feedback can you get? If I bring this thing to the product, if I give this thing to my tester, he cannot tell me feedback on the floor space or on the leg room of the car, right? There is no car at all here. So he cannot give me a feedback about the leg space, whether the leg space is enough in the car or not. So that is not possible, but he can still give me some feedback about the tires. Just a hypothetical case, if the material of the tire that I'm going to use in this car is the same as what I used in this product which I'm bringing out in the first iteration, a tester can actually test the performance of that material, how it behaves in the different road conditions, what is the customer feedback of this material, will this tire be okay, should I change the material, got it? So anything which is common between this product and the end product that you have in mind, whatever is common, you can test it right from here instead of waiting till this point. Able to appreciate? So these are the two reasons why you have to do things in increments. First is, in case you have to change your process definitions or project definitions, you still have something which you can sell to the market. And number two, you get early feedbacks from your customer and can make dynamic changes as and when required and reduce your costs significantly. So if something has to be at the end of each increment, if something that has to be potentially shippable has to come out of your iteration, what needs to be done? It has to be tested thoroughly. If going back to this previous example, if at this point I decide that, okay, my project is stopping, instead of the car, I have to sell this bicycle into the market. If this bicycle has not been tested properly by your testers, we will not have the confidence to roll it out into the market, right? So when I say that at the end of each iteration, something potentially shippable has to come out of your iteration, that means whatever you're developing in that iteration should also be thoroughly and properly tested and be ready for deployment, if at all the situation demands it. Which means, like that letter V where in Waterfall, the QA sat in another corner of the world writing system test cases, that is not workable here anymore. The tester has to be there in the same room with the developer, so that in the 2 to 4 week sprint, whatever the developer is developing, it has to be tested then and there. And at the end of 4 weeks, the QA has to sign it off saying that, okay, this is ready for deployment if there is a need. So that is a fundamental difference between Waterfall and Agile. So there is no more, actually speaking, there is no more dev and QA also. It is a cross-functional team that you talk about, right? A self-organizing cross-functional team is a term used for an Agile team. There is no dedicated developer or there's no dedicated QA. Everybody is supposed to do everything. You're supposed to do development, you're supposed to do testing, and whatever it requires for your product to come out, all that you're supposed to know, learn, and do it, right? So with Agile, what came in is that the dev and the QA, who are sitting on two arms of the V in almost complete isolation from each other, they did not have the choice anymore. They had to be closely married together. So Agile brought in the marriage between dev and QA, and they started working in close synchronization to bring out the potentially shippable product in each iteration. So this is a fundamental change. So if you look at the transition from waterfall to Agile, when the world transitioned, the fundamental difference that came in is that the dev and the QA are not in isolation anymore. They were closely working with each other. Any questions so far? Yes. Actually, I just answered that question. There is no theoretical QA, which is why I said that is a marriage that happened. So I said in the beginning that in waterfall, you had a dev and the QA who were doing their separate functions. Developer was doing his design, his implementation, and his unit testing. And there was a QA who was doing his system test cases, test plan, test data preparation, and ready to get it tested. So they were totally isolated two functions, which was existing earlier. They merged together. So the boundaries are no more clear. If I look at Agile, says there is no QA, but if you look at the practical implementation, those of you who are practicing Agile can tell, but in our projects, even when we say this is Agile, we usually have somebody who is doing the testing, though he might not be a tester, because the developer still is not very comfortable when it is his testing alone that goes in. So it's not a tester per se, which is why I said it's a cross-functional team. You are not a tester throughout your life. But in this iteration, if I'm developing a feature, I might have someone in my team doing an independent testing of what I'm developing. The next iteration, it might change. It might be he who's doing the development and I might be doing testing for him. So as in what the changes demand, that is when you do it. I didn't say manually QA. QA doesn't have to be manual, right? QA can be your automated testing. One guy can be writing your automation scripts and or automation framework. He can be developing your automation framework. So you're already practicing Agile, right? Okay. So I haven't gone into any of those CI or continuous integration or automated testing yet. I was just trying to make the transition from the waterfall to the Agile clear. So there was somebody, I didn't tell how the testing was happening. Testing would be happening in any way. Now we will come back to why the testing cannot happen in manual way slowly. But the testing has to happen. It can be manual, it can be automated, but there has to be some amount of testing. If you have to have a potentially shippable product at the end of an iteration, you have to ensure that your product is tested, right? So, and that has to happen not at the end of your product life cycle. It has to happen within the 2 to 4 weeks. So there is no way that you can have somebody somebody sitting separately and writing test cases or test automation framework or test cases. It has to happen in that very same sprint. So as and when you develop your user story, you define your user story, you also design what are the testing that has to be happen, and the test scripts or the test framework has to be enhanced. All that happens in that very same sprint. Whoever is part of the team, they all put their hands together. Clear? Not so. Okay, probably we'll go to the DevOps and then again come back to if your question is still unanswered. So the change that came in is, in waterfall, if done means it was implementation complete. With Agile, the definition slowly changed. You do not call something done until and unless it is developed and tested. So done means tested once it went to the Agile world. Any other questions? So is Agile effective? With all these changes, we said that a lot of changes have been brought in. Is Agile effective? Data says it is effective. If we can see, this red part of it has considerably reduced when the world moved to Agile, right? So my next question is, if Agile is successful, why didn't people stop there? Why did they still have to look forward, or why did they still feel that something needs to be improved? Because Agile, as you see, if it is something It was only a part of the transition. People did not stop with Agile. They went from Agile, they went to something called DevOps. Why did they have to do it? Now, the question they asked themselves is, as I said, at the end of each Agile iteration, a potentially shippable product was being developed. And it was kept ready in the shelf. In case the condition demands it, you are ready to ship it. But the actual shipment did not happen. That is what I want you to understand. Even though in Agile, at the end of each iteration, you brought out a well-tested, potentially shippable product, it was kept, that bicycle which you saw in the picture or the tricycle which you saw in the picture, that was kept in the shelf, first for the testers to test and see, get the early feedbacks. And second, in case there is a demand, you can push it out into the market, but it was actually not deployed in the market. So people started asking, if you have things that is already ready for shipment, why don't you push it out into the market and try to make some money out of it? Making money is only one part of it. Most important part is getting real customer feedback, not just from your QA or the test engineers or your closed user group or your employee trials. Push it out to the real customers and see how they feel about it. What is their early feedbacks? The example which we talked about, the tire, the material of the tire, instead of your QA people or your employees telling you the feedback, let the actual people who are going to use that product, let them start using it and get you the feedbacks. And also, they saw that even though with Agile, things improved, they were still having difficulty when they went to deploy. Who is involved when something has to be deployed? Implementers, developers? No, to roll out something into the market, yes. Which team? Deployment team, production team. Integration would have happened. That is when you test it. The operations team, yeah. So correct. So these are all right. So it is other than the developers or the testers who brought out your product and tested. What? Oh, I'm sorry. Oh. So when it comes to deployment, the operations team is involved. So earlier, even though in Agile, you had your developer and the tester working hand in hand, bringing out the shippable product. Finally, when it was ready for deployment, the developer and the QA would have gone to another project, right? Your product was ready and they have gone to another project, and that is when the operations team come and actually try to bring this out into the market, and they are encountering a lot of challenges for which the developer and the QA is no more available full time to support. So these were the two problems that they faced. One is they decided to ship it as soon as it is ready, and second, they understood that something is still missing in the link. We got the dev and the QA to get married, and we got them to work together closely, but still when the operations team come into picture, they are still at a loss because they were involved nowhere in the initial stages of the product. So then they started looking into what are the benefits of shipping. This we already discussed. If you are able to bring out something into the market earlier, you get early customer feedbacks, you get early defect detection, your costs reduced, release velocity increases, and the chances of a deployment failure are less. I have another case study, but I'll keep it, if time permits, we'll discuss it. There's a beautiful case study of how our customer went from one architecture to another when the things were actually in the market. So that's called reduced deployment failure. You reduce the risks of your deployment failure significantly by going into DevOps model. So these are the typical challenges an operations teams face with, right? So when they try to bring something out into the market, depending on what product you're working on, whether it's a product or a service or something else, the operations team will have their own challenges. What are the servers I should use? What is the scalability factor that I have to address? What kind of errors should I get? How do I address these errors? When a customer calls me, tells that my system is not working, what should my response be? All these are typically the headaches of the conventional operations team. The developer has developed, tester has tested and gone to their next project. But when somebody comes and really calls up, it is always the operations team who has to face the music. So these are the typical challenges an operations team faces. And people started looking how these challenges can be addressed a little better. And they said, now we need increased collaboration between the developer and the operations team. It is not just the developer and the QA. We need an increased collaboration between the developer and the operations team. Like, these are just few examples. Involve the operations team much earlier, not when the product is ready for shipment. You include them as early as much as possible, if possible, right in the design phases itself, so that their inputs can also be taken into account. They can tell, okay, when it is fine that your product has a feature like this, but if this feature fails in the field, I have to get this alert. This alert has to be in this format. It has to be an email alert, or it has to be a red flashing alert, whatever it is. But the operations team will tell you that, okay, I need these features also. These performance metrics has to be there, and so on. So their inputs are also taken into account while you're designing your system. Similarly, there is a more ownership from the developers of the code in production. Conventionally, when a field problem comes from the field, right, we will tell, we have a natural tendency, but it was working fine in my system. I do not know why it's failing in your system. It is not my headache. And if required, the QA person will also bring out his test report and say, see, my test report shows that this test case has passed. So now I do not know what is the problem. So these were all the conventional problems earlier. But that is not happening anymore. Because, why? Not because anybody has become very holy immediately or something. Because your development is actively happening even now. Right? It is a bicycle that went and came as a field defect. Whereas your developers and the testers are very much in the project, fully involved in the system, making the BMW. So they have not gone anywhere. So when the developer, when a field ticket comes for the bicycle, they have to answer then and there as to why this problem came, why this was not detected in our testing, what is different, can it affect the BMW that I'm making. They're supposed to analyze and fix the code before they go on to make the next part of the BMW. Got it? So it is one cycle. It is not that the operations team is working in isolation. The dev, the QA, the operations, they're all now part of a single chain. It is like an assembly process wherein whatever gets produced, gets tested, gets deployed, and the feedback comes back to the developer itself. So if I look at my project where we have this deployment, we have a dedicated team itself who's doing dev triage, which is doing the analysis of the field tickets. So the set-top box which is deployed in the market, when the customers call, there is an operations team which do the L1 triage. They just take and the moment they think it is something with the software stack, it is assigned to this team for root analyzing, giving the fix, and bringing it back as a patch to the market. Got it? So that's the difference that came in. So whatever feedbacks you are coming, the developer is there to take ownership of it and provide a fix for that. So one more element came into the circle. So now the dev and the QA, which were already working closely hand in hand, now the operations team also started working closely hand in hand. So you have the developer, the QA, and the operations working hand in hand to bring frequent releases to your customer. And now, earlier, what was the definition of done in Agile? Done means tested. So now what does done means? Exactly. So now done means in production. So you do not call something done until and unless it is released to the market and people are actually using it. So that is where your definition. So if you look at Agile, people who are practicing Agile, you have your acceptance criteria for a user story, right? Which is where you decide when do I close the user story? When do I say the user story is accepted? You do not accept a user story until and unless it has been deployed into the market with whatever criteria defined, 0 major defects or 5% major defects or whatever. But you define it that it has to go into the production. What DevOps actually means, it means that whatever you are developing as increments, it's also pushed into the market as and when it becomes ready. So that's a fundamental principle behind DevOps. Now, if you reflect back to the initial slide of Google and Facebook and all, whatever was getting committed by the developer, it immediately reaches the end user also with 0 downtime, right? That is the extreme mature stage of DevOps. And somewhere in between, you will not still have this yearly once release or once in 2 years release, you will still have releases as frequent as monthly ones or bi-weekly ones and so on. So what is a potential risk? As and when you make something ready, if you push it out into the market, what is a potential risk? The risk can be a dissatisfied customer. Earlier in your waterfall world, you had the cushion, right? You have multiple levels of testing. You have your system level testing. Then you have something called a closed user group testing. Then you have something called an employee trials if required, so that only your employees get to use it and get you feedback. So there are these multiple cushions that were able to give you feedbacks on if something is wrong or if something is not good, etc. Whereas in this case, as and when you're making things ready, you're pushing out into your real end user. So the potential risk is that if you are giving something half-baked or not properly cooked, you will have a potential dissatisfied customer and it cannot continue. If you keep on pushing half-baked things out into the market, you will soon be out of your business, right? People are not going to tolerate you anymore. So while the demand for this industry is to have speed, it has to be also done reliably. So if you remember that definition of DevOps which I showed, it was pushing things quicker, faster, but also reliably. That is very important. You cannot compromise your quality for the sake of speed or for the sake of pushing things out faster. You cannot keep pushing out untested products. And that is where the question that he asked comes in. How do you do testing? Not just testing, how do you do everything in DevOps? So if you look at DevOps, like we said, if somebody asks you what is Agile, make sure you bring out these 2 words and a person will be satisfied that you know Agile. One is you bring out increments. Second, you say potentially shippable product. These 2 are the corner pillars for Agile principles. Similarly, if somebody asks you what is DevOps, the one thing that you definitely should tell is it is continuous. You are always doing things continuously, whatever it is, whether it is development, whether it is testing, whether it is delivery, whether it is change management, everything happens continuously. That is a fundamental principle of DevOps. Doing things continuously. Now I want you to, there are only 2 slides where I'm getting into a lot of the definitions, frameworks, diagrams and all. This is one of it. So if you look at it, these are the 2 people, engineering and the QA. That is, they were already married. By Agile itself, they were married. So I do not show them separately. So the developer and the QA on one side, the IT operations on the other side. And in DevOps context, there is no clear boundary again. They have started working together in close collaboration. Now, Agile infrastructure is the framework on which the DevOps is built. So which is why we discussed so much about Agile. If theoretically you can go into your DevOps model even without Agile, but it will be a very difficult or a very tedious task for you to do. If you are doing your waterfall type of a project and you still want to migrate to DevOps, it theoretically can still be done, but it will be a huge leap for you. So that is why you naturally transition from waterfall to Agile and then you get into the DevOps principle. So if you look at the DevOps engine, it works on the Agile infrastructure as your backbone. And then you have your continuous control mechanism and continuous configuration. So all these changes that your developers are checking in. Remember that Facebook and the Google slides, 15,000 commits per day, right? You saw those. So continuous configuration, continuous control of things. And then there are 3 pillars which happen. Continuous integration done by the developers. Integration means your check-ins or your submissions or your code enhancements, defect fixes or feature enhancements, whatever you're bringing in, that gets into the trunk continuously. That trunk that gets into your SVN continuously. Then you have a continuous testing. So whatever gets continuously integrated gets continuously tested, and whatever is continuously tested gets continuously pushed out to the market. Got it? So 3 wheels always in motion, continuous integration by the developer, continuous testing by the tester, and continuous delivery by the operations team. These 3 are always set in motion and they work on a platform of Agile infrastructure bounded by a continuous control and continuous configuration mechanism. This is your DevOps in a nutshell, right? This is only theory. We will have to go a lot more. As I said, I think they are planning a series of DevOps sessions, right? So this is just an introduction. There will be very little that I can cover today, but the idea or the principle is that the basic idea behind it is appreciated today, right? So now we know these are the major blocks in this framework. Now we'll go a little more into depth and try to understand what exactly does the framework. The picture may look a little complicated, but before starting to read it yourself, I just want you to look at the outer boundary, the rectangle here. So it all starts from here with your developer doing something, writing the code, right? It has to get in continuously into the integration part. As whatever gets integrated has to be continuously tested, continuously delivery. Delivery means it goes out into the market. So from the market, the feedbacks come in. It can be either feedbacks, it can be feature requests, it can be defects, whatever. So whatever comes in, it has to be managed. The changes have to be managed. You do not fix all the defects together. You do not change, you do not implement all the enhancements together. So whatever comes, you prioritize what has to be done, and then you have a continuous change make. So this is the outer framework on which the entire DevOps works. Continuous integration, testing, delivery, and change management, right? Now we get in a little insight. So it all starts with your source code, SVMs, software version management. All of us will be using one or the other, right? In the software industry, we all use it. Can be any of those. It can be source code, SVN, Git, or anything, right? You have a continuous integration mechanism into which the developers check in your code. What happens when the developer checks in or commits anything? There is a CI, continuous integration, continuous delivery orchestration tool. So the fundamental part you have to all appreciate is that none of these things can be done manually. If you keep doing things manually in this framework, there is no way you're going to push out releases multiple times a day or even once a month. So the fundamental principle is that all this have to be automated. So there is an orchestration tool sitting out here, which tells that, okay, the moment something gets committed, the rule can be defined by you. How aggressive you want to go. Is it that every developer sitting in any part of the world, as soon as he checks in something, do you want the build to happen immediately? Or do you want the build to happen every 1 hour, every 4 hours, or once a day, whatever? It is all up to you to configure. But you have something configured which tells that at a particular time, based on the commits, you give a proper command to this build server. The build server can be anything, but you give a command from this to the build server. And what does the build server do? He checks out the code, he builds it, and whatever is coming out. So if there is a build failure, naturally there should be alert mechanisms, there should be rollback mechanisms. All that should be implemented as part of this orchestration tool. But suppose you build successfully, your image is ready, that image gets uploaded to your artifact repository. Artifact repository is something in your project which holds all your artifacts. It can be anything. It can be your test cases, test scripts, test frameworks, images, logs, whatever you require in the product, all this has to be uploaded into the artifact repository. So the moment somebody checks in something, he gives a command to the build, he checks it out from the SVM, it builds it, the image is successfully uploaded to the artifact. And then what is the next step? What is the next step? Oh, delivery. No. I only checked in something and the build is ready. Testing has to happen. As a developer, I just checked in something. I checked the defect fixed. I think the defect is fixed. Now, probably that defect is fixed. Now, who has to ensure that there is no side effect? Because it is going to reach your end customer. So in the process of one defect fix, if I have caused a serious side effect somewhere, I have to catch it, right? So there has to be a testing. So this is only the development part of it. If you look at it, it's only all this light blue color ones are belonging to continuous integration. So only the continuous integration thing, the commit, the build, the image uploading has happened. Now comes the test and lab management. So the dev part is over. Now the QA part comes in. Again, nobody sits here, comes manually and does the testing here. What happens is it is automatically triggered. The moment the commit happens, the build happens, and the moment the image is uploaded, here again a trigger comes here to your test and lab management, and that automatically triggers your testing. Now, what level of testing you have to do? You define. Do you want to do only sanity testing? Do you want to do only a quick testing? Do you want to do your full functional testing? Do you want to do a regression testing? It is up to you to define and configure. But the thing is, once you defined and configured it, it happens automatically. So based on the configuration that you have set, as soon as I get a notification that my image has been uploaded successfully in the artifact repository, the next machine is set into motion and it starts testing it. Now for testing, what does it require? It requires the test info. It requires what has to be tested. It requires what test data, all these things. It should all be uploaded already in the artifact repository. So based on the configuration that you have set, all these things are pulled down. Test info is taken out. The image that has been uploaded from the build gets downloaded to the system under test. It can be anything, whatever. Is it a server? Is it a set-top box in my case? It's something else in your case. Whatever is a system under test, the build that has just been completed gets downloaded to the system under test, and the test that you have configured gets triggered automatically, and the latest build gets. Okay. And what happens after the testing is done? The test input is given. So the test info is taken, the test input is given, the image is downloaded, the testing happens here, the test output comes back, and the logs get uploaded to the artifact repository for the developer to do a debugging or whatever. So the testing part is also over. Now we are looking at the best case. Suppose there are things here, suppose things are breaking, you have to have your alert mechanisms and people have to sit and debug why it happened. Suppose the testing happened properly, the results get uploaded here, and this is your decision maker. So this decision, there will be dashboards. This is also an important part of DevOps. You cannot depend on manual emails or phone calls or any alert mechanism. All your consolidated results have to be rolled out and shown in a high level for your senior management to take a decision whether I should say yes or no for a delivery. Right? I cannot expect the senior manager to come and ask what is the pass percentage or which test case passed, which test. It is immaterial for them. So you define upfront what is the success criteria, what is the release criteria for me, and that release criteria has to be properly concluded from all these operations and displayed in a dashboard for somebody to take a decision yes or no. If they take a decision yes for release, the switch closes here and whatever became ready, that image gets pushed out to the market. Delivery happens. If the decision is a no-go, it goes back to your developer to do the defect fix or the enhancements or whatever is required. Clear? Do you want me to go through it once again? Because this is only fundamental slide of DevOps. Every time, next time you think about DevOps, make sure that this picture comes to your mind. The thing is that it's a circle. Nothing stops anywhere. It's a constant circle, not circle. It's a constant process that keeps on happening. There is no logical closure where you say that, okay, development complete. It goes on in circles, and inside each circle, you have all these things happening. And in a full mature DevOps organization, this will be happening several times a day, right? In a company which is transitioning to DevOps, this might happen once in a month or once in 2 weeks or something like that. And in a waterfall model, how often does a delivery happen? Once a year if you're lucky. So this is a fundamental DevOps framework. As I said, if you can look at it, there are multiple tools, but I really do not want to get into the details of the tools here today. Just want you to understand this. I'm not even going to go into the details. So there will be different framework elements involved. For each of this, there's a functionality and there are multiple tools that you can use. So once more, I want you to reflect back in the definition of DevOps. DevOps was not a tool or a framework of tools. It was a culture and an environment where you make that shift, that paradigm shift, that there is no development, there is no testing. They are all parts of the same chain. The end goal is to get a proper product out into the market. Whatever it takes for you, all that has to be done by whoever is in the process. That is the environmental change or the cultural change that we're talking about here. And everything happens continuously. And if things have to happen continuously, what is important is automation. Without automation, you're not going to reach anywhere. And when I say automation, automation is not just test automation here. Automation in anything and everything you do in all walks of that framework which we saw. Starting from your SVN check-in. So what happens in our case is that when somebody does a check-in into your Git, automatically the code review gets triggered in Gerrit. the email notifications goes to whoever is the reviewers. They have to do. The moment there are 2 people are approving this review change, it automatically gets pushed to the trunk. The build mechanism triggers, the check-in happens, the testing happens, the quick test happens first to ensure that, so if it's a set-top box, the first quick test happens in just 5 minutes, just to ensure that the video and the audio comes up. That is a very basic sanity test for a set-top box. If the audio and the video is not coming up with my latest build, there is no point in taking any other further testing, right? So that's the first quick test that happens. The moment the build is ready, immediately, automatically the audio and video is tested. If that is ready, then notification goes to the different testing suites, saying that, okay, you can do your functional testing, you can do your stability testing, you can do your regression testing. All these are again automated. Automated triggers go to this different component testing, functional testing, regression testing, stability testing. All of them are set into motion. The results from all of these are consolidated, analyzed, and finally that results uploaded and rolled back into your dashboard for the senior management to take a decision. So when I say automation, automation is not just test automation. It is the complete workflow automation that has to be done, right? Okay, now, so that was a fundamental principle of DevOps. Now, there is no clear cut, you have to do this or you have to do that. Now, these are a few practices that I'm going to discuss with you now, which can be used in DevOps, which need not be used in DevOps. It depends on the product that you're developing. It depends on the industry in which you're working. There are multiple things, but these are all some of the common practices that is usually adopted in DevOps. One is, when we say software version management, typically, wherever when we were all initially starting off, we had something like this. What is this? These are all branches. So you have a trunk here for each project. So suppose I'm making a TV for the US market, for the Europe market, and for the Indian market. I will have one branch for the US. I'll have another branch, another master branch for Europe. From that, multiple branches for Germany, for Italy, for France, because there will be small changes in the standards, in the broadcasting standards. So there will be small changes required. For each country, I will have one branch. There will be separate product teams for each of those. For France, there will be few developers. For Italy, there will be few developers. Now, they are concentrating only on their product. So when there is a defect that comes from France, they will fix it only on the France branch. The Italy people will have to wait until the defect is reported by the Italy consumers, right? Because nobody takes care to merge the defect back into the Italy branch. Are you able to appreciate this? I don't know how many of you have worked with this, but we have typically worked in this, which becomes a headache. The more complex your product becomes, the more lengthier your project duration becomes. It becomes a mess to handle this in the end, because nobody knows what has been fixed, what has been merged back, what has not been merged back, what has been tested. Nobody has any clue at all, right? And similarly, what happens sometime down the line, okay, you finish this product. So Europe, everything has been successfully deployed. A few years later, the product management decides that, okay, now I have to bring out a TV into the US market. What do? You take out a fresh branch from here. It hasn't got any of the fixes that were made in France or Italy or Germany or anywhere, because the trunk is old. For France and Italy and all, you branch somewhere here. After that, all that happened here, nothing has been merged back, or some has been merged, some has not been branched. Nobody has tested it. When you decide that you want to make a US product, you make a fresh branch out of here, and you have to do all your testing again, and you have to wait for all these defects to be discovered once again in the US based product, right? So these were all the typical headaches. And as the time between mergers increases, the difficulty of merging exponentially increases. This is again a pain, not for your simple 1 month, 2 month long duration projects, no, but for lifelong projects, typically in our cases where a TV or a product is launched into the market, it stays there for many years, right? So you keep getting the maintenance phases and all that. So then this becomes a real mess. So one of the philosophies that is adopted now is what is called a trunk-based development, TBD. As you can see, this boy is controlling the elephant, or trying to control the elephant by the tip of his trunk. That is why the name comes trunk tip of the trunk development. Now this is your trunk. This is your main branch. Yeah. And every developer makes sure that he commits only to the branch. So these all the C that you see are the commits made by the developer. I do not know if you remember, but the very first slide which I showed on Google had said that all commits happen on the trunk. There was one line which said all commits happen on the trunk. This is exactly what that means. Every single developer, irrespective of whether he's working for the US or the Italy or the Europe market, he makes sure that his changes are committed to the trunk. Now, there are release managers responsible for each of these markets. The release manager does something called a cherry pick. He decides, okay, for Europe, I need this fix. For US, I do not need this fix. For US, I need some other fix. So that is called as a cherry pick. So he checks, so there will still be a branch, but what goes to the branch? Earlier, if you compare, everything goes to the branch, and what comes back to the trunk is nobody's responsibility, because nobody is actually responsible for the trunk. Here, the paradigm shift is that everything is pushed into the trunk, so you are in no way losing anything out from the trunk. You are ensured that all your changes, all your enhancements, all your defect fixes are there in the trunk for sure. Now, it is a release manager's headache whether you want it for your product, you better cherry pick from there. Because I am responsible for my product, I'll make sure that the required fix is cherry picked. So this is a totally reverse mechanism to what we were used with. And then these branches are as short-lived as possible. The moment you have your next patch coming up, this is terminated. Nobody is going to maintain it anymore, because the more branches you have to maintain, the more headache. So you just you branch it out at the last minute. You keep the branch alive for as minimum a duration as possible. And the moment your release has happened, you terminate it. The next patch release comes, you again branch it out from here and does the cherry picking and release it. Okay. So this is one commonly used philosophy now, which is called the trunk-based development, which, as you saw, Googles and Amazons and of the world are already using. Coming back to the test infrastructure, as you rightly pointed out, you cannot sit and do your manual testing, right? Simply not possible. If I have to push out a release every single day, multiple releases every single day, I cannot expect a manual tester or a team of manual testers to sit and do the testing. As you saw in the third slide, when the deployment started from 1.5 million to 15 million, my team size did not increase from 50 to 150 or 250 or 1,000. It only increased from 50 to say 55 or 80 at the max. So I cannot afford to do manual testing, and I have to have a build and test infrastructure. And these are a few of the qualities that the build and test infrastructure should have. It should be simple, because I do not want the developers to understand whether it is a Java-based test automation framework or a PHP-based or anything. He simply will have to, it should be as dumb as possible for him to use it. Otherwise, they will stop using it and you will end up in big problems, right? So you have to ensure that your test automation framework is as simple as possible for the developers to use it regularly in their day-to-day activities. There has to be speed, because DevOps is all about speed, and there should be quality feedback to developers. Suppose your automation framework failed. It said that 10 of your 15 test cases failed, and the developer has no clue why a test case failed. He's not going to even look into the defect, right? So there should be enough functionality, logs, for him to do his debugging analysis and to understand why a particular test case failed. So these are all typical things or principles that you have to keep in mind when you're developing the test automation framework for your DevOps environment. Questions?